We will solve this today's LeetCode problem. This is LeetCode hard. The question is minimum number of k consecutive bit flips, right? So let's see what the question is asking. You are given an binary array nums and integer k. A k bit flip is choosing subarray of length k from nums and simultaneously changing every 0 in the subarray to 1 and every 1 in the subarray to 0. Return the minimum number of k bit flips required so that there is no 0 in the array. If it is not possible, return -1. So basically, here we have given nums array which consists 0 and 1 only, right? And we need to we need to make we need to make all the number we need to make all the zeros of nums array to 1. For that, we had given a operation to do that we can choose a subarray of length k and change all the bits from 0 to 1 and 1 to 0, which is present in the subarray, right? So suppose we have given 1 0 0 1 0 1. So when and k is given like suppose this is k given 3, right? So if I choose any subarray, suppose I choose this 0 1 0. So if I choose 0 1 0, so I need to flip all the 0 to 1 and 1 to 0. So if I choose this 0 1 0, so I need to choose, I need to flip it from 0 to 1 and 1 to 0 and 0 to 1 and then 1, right? So that's I need to flip out, right? That's the operation I need to do, right? So that's how I need to tell that how many minimum number of k bit flips I need required so that there is no 0 in the array. So basically, it can also be not possible. So if it is not possible to convert all the 0 to 1, so we will return -1 in that case, right? Okay, we have understood the question. Okay, so finally, so basically, the basic thing, the first basic thing, that when we when we flip the number, when we have 0, we will flip only the number when we got 0 any times, right? So if we got 0, I will flip it, right? So with the condition to flip is condition to flip is that the number should be must be 0, right? Must be 0, right? And also I need to flip all the numbers if I choose any k bit flips, right? Any subarray of length k, I need to flip all the numbers, right? So basically, if I see this example, in this example, k is equals to k is 3. So if I choose any subarray, like suppose starting subarray 3, right? This 3 length, right? This is 3 length of subarray. So if I choose this and if I convert this from 0 to 1 1, right? So if you see here, this 0, this 0, this 1 becomes 0, right? This 1 becomes 0, this 0 becomes 1, right? So but we want only convert to 0 to 1, right? We want only 0 to 1, but here 1 is already flip out by 0, right? So do we need to flip it? Do we need to flip it? If this 1 is ultimately flipping out to 0, so why will I do this? There's no point on that, right? After all, this 0 becomes 1, but this 1 becomes 0 now, and we want each and every 0 of the nums to be 1. So there is no need of to do this, right? So basically, if you see in the whole array, if you see in the whole array, if I choose this 3, if I choose this 3 and convert this to 0 1 1, why I'm doing this because we have some zeros here and in the subarray, if I choose this subarray, but after flipping all the numbers, I got this subarray, right? I got this subarray. Now the problem is that we already got a 0 at a starting point. So for that, I need to again switch it. So if I again switch it of 3 subarrays, it becomes again the same subarray, again the same array. See, this array and this array same. So no need to flip it. So basically, if we have got one, if we have got one, so we don't flip it simply. If we have one, we don't flip it. So this is one. So we will, why we flip it? Why we flip it? We don't flip it. Okay, we will not flip it, right? We started from this 0, right? Now we can flip only till this 3 sub array, right? We will start from 0, we will choose this, and we will flip out. Okay, let's flip out this one, this one, this one, and this one. This will be 0, right? Okay, now, so, array becomes this. Now if you see this 0 0 1, this 1 1 is already sorted, because we know ultimately that we definitely got ones in the left part of my sub array, in left part of this, before this index, right? Because we are already we are already changed all the 0 bits to only 1, and no 1 bits changed to 0. I'm sure about that, right? So this 0 0 1 is left out. Now for this 0 to be changed to 1, I need to change all the 0 to 1 within the length of this subarray, which is 3. So I need to choose whole 3, right? So what I will do, I will do this 1 1 and 0. The thing is, if you see in this part, 0 is left out. So there is no any chance, is there any chance that I can flip this to get 1? No, there's no any chance, right? You can try run, there's no any chance that I can flip this to get all the ones. This array cannot be changed to all the ones by doing any type of bit flips, right? Any types of bit flips, I cannot change all the zeros to 1. So basically we will return -1 in this case, right? But if you see here, in this case, if you see here, what some observation we get from here. If you see here, so some observation we get here. What are the observation? The first thing is that we will not need to flip, we will not need to flip 1 to 0. We will only flip, we will only flip 0 to 1, right? Why we are doing this? To get confirm that my previous element must be 1, and we don't need to move again for checking that whether we got some zeros in my left or not. That's the main thing, right? And if we see this only, then we can do that, right? Second thing is that we can only change the current flip, the current bit. We can only flip, uh, we can only flip the current bit when it is a part of a subarray of length k, right? The second thing is that, okay, so basically we need to only flip. So how we will do that? How we will do that? We have seen that we need to flip only the subarray and 0 to 1. So how we will do that? So one thing, if you observe here, that if I check any of the elements, let's take this, let's take this, let's take this, right? And k is given 3, right? So if I want to start from this point, because we are stating from left point, right? We are iterating from left point. If we try to start from this left part, this is 0, right? This is 0, and we need to flip from 0 to 1, right? We need to flip from 0 to 1. So if I try to flip this, so if I try to flip this, it means I need to flip all the bits which are in present in this subarray, right? Because we can only flip all the we need to flip all the bits which is present in subarray, and subarray length should be 3. So if I want to flip this 0, so I is equals to 0. If I want to flip this 0, I need to flip all these numbers, right? So how we will keep track of this? How we will keep a track of this? So if you want to flip all these numbers, so basically, can you just count the flips? Why we are counting this? We will see this. If I just count this, suppose this is 0, I will flip this, so count will be 1, right? Okay, count is 1. It means I have already flipped this. I have already flipped this, right? And till which index I can flip this 3 part? It means 0 1 and 2. It means if I have flipped at I is equals to 0, so that means I need to flip all the bits which is present till I is equals to 2, because k is 3 and I is 0. So till 0 to 2 I need to flip all the bits, right? Okay, The second thing, when I go to I is equals to 1, I will see that I have seen that we have already count 1, and which is which we have already flipped till I is equals to 2, right? Till I is equals to 2, I have all the we have already flipped all the bits, and the count is 1 here. It means this 0 and this count 1, this 0 and this count 1, we already know that we have already flipped its previous elements. It means we have already flipped all the elements within this range. So this 0 is already become 1, this 0 is already becomes 1. So do I need to flip again this? Think of that. No, I don't need to flip this, right? Because this 0 is already flipped. 0 at index at index 1 is 1 already got flipped, so, and it changes to 1, so why we don't need to, again flip that 0, right? Again we don't need to again flip, because if we flip again, that 0 will become 1, right? So basically what I'm trying to achieve, I'm trying to just see that if we have a fixed window, which is k, if we have a fixed window which is k, right? This k is fixed. It means we have a fixed window of length k. So basically if I fix this length of this 0 to 0, it means I have already counted 1. So basically 0, if we have 0 at current bit, as current bit, and the count count is count is even, do we need to flip the bits? If we have 0 as a current bit and count is even, it means the we have already flipped my we have already flipped the bits in previous. So do we need to again flip this? So 0 is current bit and count is even. So if you see, if count is even, so suppose count is 4, so this 0 flip to 1, 1 again 0, and 0 to 1 again, right? So if count is 4, it means, if count is 4, it means we have flipped 4 times, right? So if initially it is 0 and we have flipped again even times, it will become again 0, right? It will become again 0. But if this 0, if this count is odd, let's suppose 3, so 0 to 1, then 1 to 0, and then 0 to 1, it means we will change 0 to 1 ultimately. So even and odd of count represent that whether the current bit is 0 or 1, depends on the parity of count and the current bit, right? What does mean parity? Parity is something like 0 is even and 1 is odd, right? So this is the thing, right? So how we will check that, right? How we will check that? So basically if 0, if the current bit is 0, let's make a table, current bit and the count, right? Current bit and count. If the current bit is 0 and the current count is even, right? So basically, do we need to flip it? Yes, we need to flip it, because ultimately if you see this current bit and count, you will get 1, you will get 0 ultimately, we will get 0, right? So it need to be changed, because this 0 is the current bit and the even count is even. So we need to change this to 0, so it need to be flipped, right? It need to be flipped, it need to be flipped, right? The second thing is, if it is 0 and if it is odd, right? If it is odd, so if it is odd, it means it will already change to 1, right? So we don't need to flip it, because we don't want to change 1 to 0. We don't need to be flipped, or let's make just we need flipped or not, right? Flipped. So we need to flip it, right? We need to flip it. Uh, we need to flip it. How to represent it? Let's just make it okay, right? Right. So we don't need to flip it. Just make it a cross, right? Okay. Let's suppose this is one again, and this is even, right? So if this is even, it will again, it will be one only. So if it is already one, we don't need to check. Don't need to flip it. So it will okay, right? And if it is zero, and if it sorry, if it is one, and if it is odd, if it is odd. So main thing is here observation that if it is a one and the count is already odd, it means it changed to zero. It's already changed to zero. It means if it is changed to zero, it means I need to flip this zero to get one. So I need to basically flip that. I need to basically flip this, right? This is not okay. I need to flip this, right? I need to flip this, right? So basically, we want to change from 0 bit to 1. So either 0 is already changed to 1. Sorry, this is 1. Okay, I need to flip this, that, right? I need to flip this, the upper part. I need to flip this, and I don't need to flip this, right? Right. So if 1 is already changed to 0, because we have already changed any elements bits present in the that subarray which is current bit. So if due to that, if it is already changed to 0, I need to flip this again to get it 0, right? That's the motto of this. Now we will use this, to see, right? We will use this. So basically, if 0 is even, 0 is current bit and count is even, and 1 is current bit and count is odd, so we need to flip this. Remember that, right? Now we got some observation here. Now we will check for something. So we have a fixed window. We have a fixed window of k-length subarray, right? We know that. We have already observed this thing, right? Zero and is even. Count is even. Odd, one and count is odd. Then we will flip this, flip the flip, right? And if we flip, I need to, and if we flip, I need to make the flip for all the bits, for all the bits for current subarray, for current subarray. So this is we know, right? Okay, this is we know. Okay. Now, the thing is here, we have some observations. Now, if I check for some examples, how we will do that, right? Let's suppose this is given 0 1 1 0. Okay, let's take this example, right, which is given in this, to make you understand that how this works, right? Definitely. So the motto of this, to just count the number of flips, and on the basis of that check the zero. We need for the current bit, should be flipped or not. The basis of that, the motto of that, the motto of that is, we don't need to, we don't we don't need to worry about the left bits which we have already seen, right? The motto of that, the logic, the the intuition behind to check this for fixed window, that we don't need to worry about the left bits which we have already seen, right? Why we are Because if I again go moving in from the starting point in the array, so that will definitely give me uh, some headache, because I we don't know na, that we have changed already 1 to 0 or 0 to 1. If I change, suppose this I change 0 to 1 1 1, and then we again change this part, so this one becomes 0, right? This one will become 0. Now again we will start from this part to check that whether zero is already one or one is already zero or not, right? So that's need to be, that's no, don't need to be checked again and again. That's why we are just checking for a particular subarray and maintaining a count. And if that particular subarray is enough, that we have already changed from 0 to 1, then we will move in further part before without worrying from the left part, right? Without worrying for the left part. So now if we see here, if we see here, the first thing is we will start from 0, right? We will start from 0. The second, the count is 0. And the third is till, till where, till where I need to check this, right? Till where I need to check this, right? Okay. uh, till where I need to check this. So the first thing is here, if you see here, the first thing, number is 0, number is 0 and count is also 0, right? So it is even, and it is even, it is already 0. It means 0 need to be changed because it is ultimately would be 0. So if 0 would change, we will flip this. And if I flip this, it means I need to flip all the all the bits present in the subarray starting from this element, because we can flip all the, we need to flip all the bits which is present in the subarray, and k is 3 here, right? So from 0 to 2, from 0 to 2, we got a count 1, right? And we will use this count 1 to check for 0 to 2, right? It means till, till index, till index, till index 2, I got count 1, and we will remember this count 1 till the index 2, right? Now we will move to 1, and we will check whether this 0, this current index, is within this index. Yes, it is within this index, right? It means I need to check this count also, right? So this is 0 and count is odd, right? Count is odd. And if you count is odd means this 0 is already got flipped, it's already got flipped. So 0 is already becomes 1, 0 is already got becomes 1. Do I need to flip this? No, it is not. It is already 1. Why we are, why we flip this, right? So I don't need to flip this, so count will not get affected. Now I will go to 2. This 2 is within limit of index 2. It means I will check again for this count. This count is odd. It means this, this 0 is already converted to 1 due to its previous elements, so it will be 1 again, right? So it not to be, it does not need to be changed, right? So the count is already 1. Now when I go to this one, I is at 3, which is greater than this limit. Because what does it mean? Window is already over. What does it mean? Window is over, right? Window is over. We are out of bound, right? Now if we are out of bound conditions, if we are out of bound condition, it means this, till which index, till 2 we have only only remember this count. Now this 2, this 2 part, this 2 part, this 2 part should not be remembered. This 2 part should not be remembered, right? This 2 part should not be remembered. So if this this should not be remembered, what I will do, I need to, but if you see, I need to change this count to 0, and also we need to remove this. Now I will check on the basis of only one, right? Whether we need to start the sub array from here or from the later on, right? Now this count is 0, but the in the previous window, how many counts we have there? We were count 1 only, right? Because the count was 1. Now for this 3, we can start over the new window if we need to flip it, right? If we need to flip it. So now if you see this 1 and this is 0, right? So do I need to change this? So the count is already 0, it means it is even, and this is 1, it is already 1, it is already 1. So we don't need to flip this, right? If we don't need to flip this, I will not do anything. I will not start a sub array from here, because if I don't flip this, why will I start a sub array, right? I will not touch this and not start sub array. It means we don't need to do anything. Now we will go to 4. Now the 4 part, I is equals to 4, this is 0 and this is count 0, it means it will be ultimately 0. I need to flip this. If I flip this, count is 1. And if I flip this I need to flip the whole bits which is contained in the subarray. It means I need to maintain the index till where I need to check. It means it is at 4, it means I need to check till 6 part, right? K is equals to 3, so 3 lengths should be there. So till 6 I have count 1. I need to check for each and bit that whether you are 0 or 1 according to this count. Now when I go to 5, this 1 is odd and this CNT is also odd. It means when I change this 1 count times, it ultimately will become 0. Now it is 0. It is 0. It means I need to flip this. I need to flip this. It is 0. It is 0. I need to flip this. It is not. It is currently is 1, but due to this 0, it is. We have already flipped this array. Na? We have already flipped this subarray. So due to this 0, it already got flipped and it becomes 0. Now for this need to be 1, I need to make another subarray to make this 1. So for that I need to again flip this. So when this 5 is 1 and I need to again flip this, it means for this, for that, I need to simply check till which index I need to flip. So this is at 5 and till 7 I need to flip this, right? Till 7 I need to flip this, right? Now the count is, 2. Why it's 2? Because when you move from this 6, so for this 6, there are two counts. One count is for due to this 0, another count is another flip is due to this 1, right? So total number of flips for this one is 2, right? Because this will be a part of two subarrays, right? One subarray is started from 0 and one subarray started from 1. So this one is part of the two subarray, so we need to check for the two flips. If I do two flips for this one, it will again got 1, so I don't need to flip this one because it is already 1. So I will start from, now I will go to I is equals to 7. Now we will check this 7 is already inside my index my 1, this under this 7, right? So under this 7 is already under, so this is 0 and we need to flip it now, right? So do we need to flip it, right? Do we need to flip it? The question is, do we need to flip it? If you see here, we can we don't need to flip till 6, right? But it is 7, right? We don't need to flip till 6 because we have two index now. One is started from 0 and one is started from 1. So the first is still 6 and second is still 7. So due to this 0, this is due to this 0 should not get affected by this 0, right? Because the window size is still this one only. This 0 will only get effect due to this one, right? Due to this one. So till this 6, the 7 is greater than the 6, it means this need to be removed. This need to be removed. So if I remove this, so I need to also decrease this count to 1. I also need to remove this count to 1, right? Because the count is 2 for this only 1, because it is a part of two subarray, but this 0 is count part of only this one subarray. So this need to be 1 and this count tail index is 7, which is inside this. So this 0 is even and this count is odd, it means it is already 1, it means I don't need to flip this. So ultimately I got ultimately I got this one and this one, right? ultimately I got Ultimately I changed all the zeros to 1s in 3 flips, right? If you see randomly, one flip is required to change this 0 to 1. The second started from can be started from this 0 to 1, so this becomes 0, this become 1 0 0, and the third will be started from this 0, and we ultimately got the same thing, right? So basically what we need to do, we are we are maintaining we are maintaining that till which index till which index I need to I need to flip if the current bit is got flipped. If the current bit is got flipped, till which index I need to flip, and we will maintain. We will check check till that index, that whether we need to flip the current bit or not, right? So if you see, rather than maintaining this count for current subarray, this count is for maintaining the, it is for only to maintain, it is maintaining the count of flips for a particular subarray, right? It is maintaining a count flips for a particular subarray. So if you observe here, instead of maintaining this count extra variables, if I just see this, that how many indexes are we have, how many indexes we have, right? Instead of maintaining this count of flip, how many indexes we have, that was the same count, right? The previous one, we at one, we was at, we have two count, and we also have two indexes in our hand, 6 and 7. When we have are at 6 point, I is equals to 6, the one is due to this and the second is due to this. So we got two indexes, last index for this current index, and we also got two counts. And for this zero, it got removed, and this also changed to 1, because this 0 have already effect only this, due to this 1 only, right? So if you see here, we don't need to maintain this count, we will just check this, that how many indexes we have at the last index, right? We will just check this, right? So what we need to check, we need to just check that uh, how many sub arrays, in how many sub arrays that in how many sub arrays the current bit is included. What does it mean? It means that that much times the current bit needs to be flipped, right? One thing you have observed here, that the index, the final the window size, the last index which is at here, the last index which is at here, index which is at here, comes first, comes first and should also be uh, go first, right? If you see here, the 6 and 7 comes there, 6 comes first and 7 goes later, goes later on. So 6 need to be removed first, because uh, it is less index than 7. And when the 7 is when we go out of bound, the 6 and it's need to be removed. So it means I need to insert this last index anyhow, that it comes first and should go first. So do you think of any data structure, do you think of any data structure do you think of any data structure which do this? Yes, Q data structure. Q data structure do the same thing. The first in, first come out, right? It's work on FIFO. First in, first come out, first out, right? It's work on the same principle, right? So we will use to store that which index this needs to be checked. So we will store this in Q data structure, right? We will store this in Q data structure. So basically, what we do, we will we will the final conclusion is that we will check the bit, we will check the current bit, if it is, if it can be flipped on the basis of these conditions, on the basis of these conditions, right? On the basis of these conditions, right? That zero, if it is 0 and it is even, it's need to be flipped, because ultimately it will be 0. If it is 1 and it is odd, it is ultimately 0. it will be ultimately 0. So that needs to be flipped, right? I need to flip this, right? So the current bit and is 1 and count is odd, so it will be ultimately 0. So I need to flip that, right? So basically, that's the whole point of this problem, right? So if it can be flipped, we will flip that. We will flip that, right? Now the second thing is we will maintain we will maintain the last index till we can flip right? and and also the current bit will know that how many in how many subarrays in how many subarrays it is in how many subarrays it is a part of that, how many that it is a part of in how many subarrays, right? The current bit should know that that uh, that in how many subarrays and how many that it is a part of it is a part in how many subarrays, right? It is a part in how many subarrays, right? Basically, uh, it should be known, and on the basis of that we will uh, insert this queue and maintain that order. So let's try to implement this, basically, so we will be better understand. The logic is the same, that we don't need to worry about the left part. That's why we are iterating from left to right and maintaining the sub arrays from the left to right, right? So that's the whole purpose of this question. So we will implement it and dry run it to better understand, right? So let's just implement it. So basically what we need to take, so basically we need to maintain the windows and the sub arrays, right? So first thing is to take a queue data structure to maintain the last index of a subarray. If we take a subarray, right? Now, okay, one thing is also that we need to store the count, so that would be a final answer, or that would be our final answer, right? Now we will start from 0. The first thing that if the current element is 0, if the current element is 0, and also I need to check the count. So I have already told you the count is same as the number of index which is present in queue, right? The count is same as the number of index which is present in queue, because it will just tell you that the current weight is part of how many subarrays. And what does it tell? That it means that how much time the current bit needs to be flipped, that is ultimately equals to the count, right? So it means I need to check its size, q का size, right? I need to check its q का size. So if num size is 0 and count is, so in what are those two conditions? These are the two conditions which I need to flip. So I will check only those conditions. So current bit is 0 and the count is even, so I need to flip this. So if current bit is 0 and count is even, it means count is even, right? So I need to flip. So if I flip this, answer would be plus plus. And if I flip this current index, so I need to flip all I need to maintain a sub array for that. So I need to insert the last index of that sub array till where I need to flip. So what would be the last index? So that would be I plus k minus 1. How this comes? K is suppose k is 2 and we are at 0. So till how many till which index I need to till which index it will be a sub array? K is 2, so that would be 0 1, right? So 0 plus 2 minus 1, which is till 1 index, right? That's it how I plus k minus 1 comes. Okay. Else, till which part we need to check. This is the first condition. The second condition is if num size is 1 and count is odd. If num size is 1 and count is odd. So the second condition is if num size is 1 and count is odd, right? If this condition holds, either this condition and this condition, this cannot be concluded at once, because the count, either it can be even or odd, and num size can be either 0 or 1, right? So this need to be also flipped, and there will be also, because ultimately if you see this will be 0, right? This will be 0, so I need to flip this. So if I flip this, I need to still maintain a sub array according to that, and count will be increased. Now now one thing is there. One thing is there, that if, what if this current index is greater than, is not within the limit of this queue. If you see here in this, we have checked that this 7, before it was 6 comma 7. So when I move to this 7, when I move to this 7 part, this 7 part when I move to the 7 part, this 7 is already greater than this 6. 7 was already greater than 6. It means we don't need to check this. So we will need to remove this, right? If I remove this, this q will size already becomes 1. So I need to remove the I need to remove the current part if it is not uh, uh, it is not in within limits. What does it mean? It is not in my current window. It is, if it is not in my current window, if this current I is not in my current window, so I need to remove that. I will remove that. So what does this queue do? It checks that the front part, that the first element which is in queue index is less than my current index. It means this I is out of bound. I is the current index I is not a part of the previous, is not a part of the subarray. It is not a part of subarray which is in q dot front. That's meaning to check it. So we will remove this, remove that the last index if it is not a part of, right? So we will simply remove that, right? So before checking this q dot front, I also need to check whether this queue is empty or not. Whether this queue is empty or not, to handle the edge case, right? So I need to check this queue is empty or not, right? And if all satisfied, if all the satisfied, so I will check at last that I will just return answer if and only if we don't have anything left in queue, right? We don't have anything left in queue, because if anything left in this queue, it means we have we definitely not changed anything in my we definitely not changed anything in my sub array, right? Something is left to be flipped out. So it means basically I need to check whether my queue is empty or not. Queue is empty or not. So if it is empty, I will return answer. Otherwise, it will return minus. So let's just take an example and write on this. You will better understand. Uh, let's take 0, 0, and 1, again 1, or take it as 0, 0, 1, 1 and 1 and 0, right? Basically, take this, right? So if I take this example, let me verify it whether we are at right position or not. And let's take k is equals to 2, right? So this to be flipped, and this to be flipped, and this to be flipped. So okay, let's this will never be gives us, we will not able to change this 0 to 1, right? So we will check that, right? Well, right. So we have q, right? We have q, and now this I, this I is at 0, and answer is at an answer would be at 0, the total number of counts which calculated, right? Now the q is the num size, the current weight is 0, I is at equal to 0, so it needs to be flipped. So if I flip this, till which index it need to be flipped? Till one index, right? Now the thing is, when you flip this till one index, uh, I is equals to 1 now, right? And the count is also 1 because we have flipped this 0. Now this one is already within this limit, right? Within already this limit, and this 0, so the count is on the basis of q dot size, so the count is 1. And if you see, this current is 0 and the count is 1, it means ultimately it already got 1. So do we need to flip it? No, we don't need to flip it. So we not flipped it, but when we go to move this one, we need to remove this q. We need to remove this q, right? So that's why I have written that I is greater than q dot front, so we will pop this out. That's why I have included q, right? Either you can include this q here, or either you can change this to upper part, right? Either you can do this here, or you can check this to upper part. That's the same thing. That would be the same thing. Either you can check this here or at upper part, right? So what we I have done, that I am checking that whether my current front part is same as the my current index, because if it is the last index, after that I am sure of that it's need to be removed. So I am checking after checking this bit, that whether my current index is present in the front part of my queue. If it is equals to that, I will remove that. So I have removed that because it is achieved it, right? Now when I go to 2, when I move to 2 when I move to 2 when I move to 2, this q dot size is 0 now, so the count is 0. But the scene is that this is at 1 and count is 0, it means this is ultimately 1. So do I need to flip it? No, I don't need to flip it. And do I also need to worry about the previous lefts? No, because we have already changed this 0 to 1, and we are not changing 1 to 0 at any in the case, right? So we don't need to worry about the previous cases, right? So uh, we can move further without worries, right? Without any worries. Now I becomes at 3. Now this is at 0, which need to be flipped, right? Which need to be flipped. So if I need to flip this, it's changed to 2. And also I need to mark that last index. So what would be the last index? 3 plus 2 5 4. This 2 be this 2 is can this 2 is a part of stats about it. So q is at 4, right? Q is at 4. Now q is at 4 and I is equals to 3. It is already flipped. We will change to 4. Now when we move to 4, we will check the count q dot size, which is already 1. So the count is 1 and it is 0. It means it is ultimately be 1. It means we don't need to do anything of this. But this is at 4, which is the part of which is the same as the q dot font. So this need to be deleted, because after that it will be go out of bound. So it will need to be popped out, and we will change this to 5, right? Now this 5 is at 1, and count is empty, right? So it's to be 0. It is already 1 and it is 0. It means it don't need to be changed. It don't need to be changed. So we will move further to 6. And when we go to 6, this nums I is 0 and count is 0. It means it's need to be flipped. If it's need to be flipped it will store some element which is 6, and after that it becomes 7. But this will go out of bound and q is left with something. And if you observe, this 0 is not still is 0, it is not changed to 1. That's why we have got this q, that if q has some elements present, it means we have definitely some elements in my arrays which is not got flipped to 1, right? That's why we return -1 in that case if it is not empty, right? That's the whole mode of this problem. Instead of this 0, if I add this 0 again, so this 7, it is here, right? So if I flip this 0, it it will flip till 8 elements. It will flip till uh, sorry, if it is a 6, right? If it is at 6, so if I flip this, it will move to till 7, right? It will move to 7, and answer will be 3. So when I go to I is equals to 7 and count is 1, so now this is already flipped, and it will go, and it is 7 is equals to the 7, so it needs to be removed, and it becomes empty again. So now the case is that we have already q is empty, and we have already flipped all 0 to 1, so that's why we return answer. So that's how this is working, right? uh, I think you I hope that you understand all the things, right? I hope you understand all the things. Let's just try to uh, run this code and see we are working this or not. That's the how we write on this code. Something is wrong. We will see that. What is wrong? We had changed this q, answer 0. Logic is correct. Something is missing. Let's just try to see that. What is missing? Q dot size count should be even. Okay. I plus k minus 1. If num size 1, count should be, if count is odd, it should be also removed. If q is empty, if q is empty, that should be checked, and if I is greater than q dot front, I will pop out. And at last, if q is empty, okay, q dot empty is true, then I will return answer, right? So that is the problem here. If q is dot empty, I will return answer, otherwise I will return minus 1, right? That's the problem. Let's just try to submit it. Yeah, we have successfully solved the questions, right? So basically we are just, so the question is just a sliding window approach with uh, remembering two three things, right? It's a sliding window, but not a not a basic sliding window, right? Not a standard sliding window, right? It's something is sliding window, but not a standard sliding window. There's something needs to be observed, right? Many things needs to be observed while solving this question, right? So basically, yeah, this is a really hard problem. This is a really hard problem. If this comes in your interview, if you have not solved it, you will you will not able to grasp on that time of for sure, if you have not solved this type of question before interview. So I will surely tell you that you need to solve this anyhow, and I hope you have understood this all the concepts, because this type of things, this counting and checking, it used in many problems, right? These concepts used in many problems, that if you want to flip questions, so you need to count anyhow and change according to that. This concept used in many of the questions. So basically you need to understand this, how this works. And if we understand the time and the space complexity of these problems, so time complexity is, we are iterating o of n times, right? And we are not taking any extra time other than o of iterating one time, so that is will be o of n. And the space complexity is, we are using only q data structure to store the sub array part, so that you can take o of n also, because k can be 1 also, right? So that would be ultimately o of 1. So this is how we will solve the question for this problem, right? So hope you understand it. uh, there can be also many other solutions which we can use instead of this q data structure. Either you can use dq or something, or to solve this, or I think this queue should not be needed, but for now I'm not able to think anything, because this video already becomes very lengthy, right? So we can already also solve this without queue, I know, definitely for sure, but video has already been very long. So thank you so much. Bye bye. Hope you understand, right?